All right, so let me share my screen. Can you see my screen?
Yeah.
Good. Okay. Okay. So, all right, let's start off with the Anglo Chinese paper. Okay, so what do you have here? Let me see. Question 2. So it says, how many of the following figures have at least one line of symmetry? So at least one line of symmetry. So the square has 4. Oh, I talked about the line of symmetry concept with Yusing on Saturday. Okay, so over here, square has more than one. Parallelogram, this particular parallelogram has no line of symmetry. The rhombus has 1, 2, more than one circle. So the answer should be 3, yes. So for parallelogram, right? So for parallelogram here, can you see this? For parallelogram, in this case, you have no line of symmetry. I mean, this particular parallelogram, you have no line of symmetry. Can you see? Hello, can you see or not?
Yes.
So for this particular parallelogram, you have no line of symmetry. Okay, so yes, okay. So that's why you only have 3. Okay, so the answer should be 3. Okay, over here it says as a decimal. Okay, so if you are not allowed to use a calculator, and I believe you cannot use a calculator in this case, so so you should have 6, then 2/500 should be so you just okay, let me connect my writing pad first. Oh, by the way, this is the writing pad I'm using. Okay, so in order to write, can you see the writing pad? Hello.
Yes.
By the way, you don't have to mute yourself anyway, so you don't have to unmute, and then you don't have to mute so many times. You don't have to mute. Just leave it on. If you're not speaking, then I will not hear anything from you anyway. So okay, so let me connect this writing pad. So it works. The writing pad works very well. So that there is a stylus, so it works very well on a laptop. Yes. Okay, so for this, what you do is 2/500. So what you do is you divide by 2. You divide by 2 is 250. So 1/250. So it should be. So what you do here is you just use the long division method. So 1,250, right? So you put a 0 here. Okay. So still you cannot divide. So you put another 0. So you add another 0 here. So you still cannot divide. 100 divided by 250 is still. You still cannot divide. So you add one more 0. So you align. So basically you align it first. Okay. And then eventually you add another 0. Then you realize that you can put a 4 here. Okay. Then you get 1000. Right. So therefore your this 2/500, or rather this 1/250 is equal to 0.004. And then you add with the 6 in front. Can you see here? So you will get 6.004, so which is 4. Okay. By the way, these 2 questions, I think they are two very simple questions. You're not supposed to get it wrong, but it turned out you got these 2 wrong. Okay, very unnecessary mistakes. Okay. Next. Question 4, wrong again. What happened? All the easy questions all wrong. So what it says, so during which 1 hour period was the decrease in the volume of water the greatest? So basically they are asking for the volume of water, okay, not percentage. So
Why
all,
did I get?
right, what do you get? Oh, you are correct. Sorry. I was looking at this. I don't know why. Ah, okay. So the ink, the ink is too strong here. Okay, the ink is too strong here. So in fact, this thing here is from this page. Okay, so I was looking at the wrong thing. Okay, so anyway, over here it says the decrease in the volume of water. So you just look at the longest decrease. In fact, it's very easy to spot in this case. They're not asking for percentage decrease, okay? They're asking for decrease, just decrease only. Okay, so just decrease only. So you just look at the steepness of the line. Okay, next. Okay. Okay, over here it says among the following fraction from the smallest to the largest. So first thing first, you need to read the question, smallest to the largest. So you need to put the smallest first. So of course, over here, if you can see this, okay. So what do you have is, you can do it this way. So this is a mixed number already. This is also, you can change it to a mixed number. Then of course, this you also can change it to a mixed number. Then of course, with this mixed number, so I think the next step is you change this to all the denominators to, they call it the common multiple. Okay, common multiple. Okay, so the common multiple between this is, I think, is 36. Okay, so you change it to 1 and then 6 over 36. Then for this one is 9 over 36. Then for this is 4 over 36. Then you start to see which one is the smallest, right? After you change these three of them into common denominators, okay? And the common multiple here is 36. And the smallest should be this, okay? 10 over 9. 10 over 9, yeah. Okay. So then the next one should be this one. Can you see? So this is the smallest. Okay, this is the smallest, and then this is the second smallest. Then this is the largest. Okay. So you should rank it 10 over 9 first, then 1 and 1 over 6, then of course 5 over 4. Okay, why I prefer to do this question in this way, because I don't want to do it using the improper fraction. Okay, the reason is, if you change these three of them into improper fraction, and your numerator is going to be a bit more complicated. So like you say, if you times the 6 here, then you get 42 over 36, right? For this one, then of course you need to times 9, so you get 45 over 36 here. Okay, then over here you get 40 over 36. Of course, this is also one of the ways to solve it, but I prefer to do it this way. Okay, I change it to a mixed number because all this is going to be smaller. Okay, they are going to be smaller. Okay. So looks like I should not use this. I should use this. Can you see they are smaller compared to your? Okay. Okay, I can draw. Strange. Hold on. Okay, good. So can I draw? Strange, but never mind. So basically, just do it this way. Okay, just do it this way. So if you do it this way, the mixed numbers, they are simpler. So when they are simpler, it's easier for you to compare. Over here, the numbers are slightly bigger, so slightly bigger, more complicated. So I will say this is also quite unnecessary. I mean, this mistake is quite unnecessary also. Next. Okay, the rest are good. Okay, good. Oh, you have not received your mid-year results, right? Have you?
Uh, tomorrow.
Oh, tomorrow. Okay, good. So yeah, so tomorrow is Tuesday. Okay, so once you get your mid-year results, then you can actually share with me. Just text me over the WeChat. Okay, so so far so good. So far so good. Mm, mm, mm. This one is correct or what? This question.
Don't know.
What do you mean by don't know? Let me adjust it a bit. So what is this question about? So it says the bar graph shows the type of food consumed. Then the bar shows the number of pupils who consume chicken rice not been drawn. Okay, chicken rice has not been drawn, but it says 20% of the people in the canteen consume chicken rice. So basically, you have to figure out what? You have to figure out the basically chicken rice is 20% of the total, right? So 20% of the total is equal to chicken rice, right? Okay, so or another way to look at it is this equation is 20% is equal to chicken rice over the total. Okay, so over here for noodles is 120. I just read it off this bar chart. So for dim sum is, let me see, 1, 2, 3, 4, 5. So 1 unit is 2. So this one is 42, 44, 46, 48. So this is 48. Then this is what? This is 100, 100 or 110? 100. Then this one is 52. Okay. So what you have here is what you have 80. Okay. Let me see. Is it 80? Can I draw a line here? Oh yes, I can. Yeah, it's 80. Okay. So for you, you have drawn 80 of them. Okay, good. So what you need to do is once you get your 80 here, all you need to do is use 80. We divide by the total. Total is this one. Okay, this add up to this is 220, 300. So 300 add another 100, 300 add another 100 is 400. So this is 1, this is 5. Yeah, so your answer is correct. Okay, so it's 1/5 is actually 20%. Okay, so your answer is correct. So you have drawn correctly. Okay, pretty simple. This question. Just to share with you, I don't know how you do this question. But actually you can do this question by doing this. Okay, you can actually dissect. Okay, you can actually dissect this. Okay, so what I'm going to do is this. Okay, and I hope you see that. Okay, this piece, this is the unshaded part, is actually equals to this shaded part, and then this unshaded part is actually equal to this unshaded part. Okay, and of course this unshaded part is actually equal to this. Okay, let me add another line. So I'm talking about the what strategy you can use, okay, to solve such question. So this unshaded part, I call it 1, is equal to this shaded part. So this shaded part is equal to this unshaded part. So if you look at the second half of this rectangle, which is the below part, you see a similar pattern. This unshaded part is equal to this shaded part. This unshaded part is equal to this shaded part. Similarly, you see the same pattern. Okay, and then you start to realize the shaded part is actually half of the so basically you see that the shaded part is actually equals to half of the total if you are talking about the area. All right. But in this case, they're talking about what? They talk about the total shaded area is 500. So with 500, so 500 is equal to half total. Okay, so the total is supposed to be 1000. Okay, cm squared. I mean, I'm talking about the area. Find the length of QR. So they want to find this QR. Okay, so in order to find QR, right, what you need to do is use the length times the breadth. Okay, times this breadth. So length is 40. So you have 40 times the breadth, which is supposed to give you 1000. Okay, therefore your B should be 25. Okay, so that's how you get your 25 here. Yeah. Okay, so always think of this strategy. Yeah. 25 is good. Okay, 26 is good as well. 27 is good. Okay, 28 is good. Good. 30. Okay, end of paper 1. Okay, so looks like you have done pretty well for paper 1, except you have made some unnecessary mistakes at the beginning of the paper, especially the MCQ questions. Okay, let's move on. So what's this? Okay, so over here it says in the grid below, by joining dots. Okay, so they give you AB already. Draw 4 more straight lines to create 2 isosceles triangle ABC and ABD. Oh, okay. So label all points. Okay. So so it looks to me you can basically there is no one fixed answer for this question. Okay. So as long as you can get 2 isosceles triangle, then your answer is correct. Okay, so now the question is how do you draw 2 isosceles triangle, right? So one thing you can do is you can use your ruler. Okay, you can use your ruler as long as you're this line. So so basically I can use measure. Oh, good. Can I try? Let me try. So let's say if you're this length, okay, so your this length is, so it says what something. Oh, I cannot read. Okay, it's 1.01 inch. Okay, it says, okay, let me change to read. So over here is 1.01 inch. So similarly, if you can get this this side to be 0.01 inch, 1.01 inch, then you should be okay. Okay. By the way, over here, it doesn't look. This is 1.08. This side is 1.08, but here I measure it 1.01. So, they don't look like they are not the same. Okay, or at least on this screen. Okay, they don't look the same. But what I'm trying to say is, how do you do this question? If I'm going to do it here, let's say. Let me use the PowerPoint. I think your answer, I think your drawing is also a bit off. Let me tell you why your this answer is a bit off. Okay, so how do I decide whether your answer here is correct? So actually I can do it this way. Okay, so what I am looking at is your this line should be isosceles. Your this line should be should have the same distance as this line, right? So what I'm going to do is I'm going to make use of this. So over here, you go up by 1, 2, 3. So you go up by 3, and then you go to the right by 2 units. So 3 unit up, and then 2 unit to the right. Okay, so I'm expecting you for your this line, right? If you look at it for your this line, right? You have what? You have 1, 2, 3, 4. So because you have 4 unit to the right, and then 1 unit down. So can you see that these two, they don't tally? That means they don't match. So this is also another way to tell me these two lines, they are actually not the same. Okay. But it appeared, I mean, these two lines, right? They appeared to you. Okay. They appeared to you. They are the same. But actually, they are not. If I do it this way. Okay. So now the question is how to do it then. So how to do it? Any idea? You have any idea?
Measure.
No, I will say, okay, there is a reason. Okay, there is a reason why they give you this dotted diagram. Let me get this. Let me try to get this question to the PowerPoint. I will show you. Okay, let me clear this one first. Let me clear this one first. Let me transport this diagram to PowerPoint. When you are given a dotted diagram, right? In fact, they want you to make use of the dots here, okay, instead of measuring. Okay, so try to make use of this dotted diagram. But anyway, let me zoom in first so that I get a bigger diagram. Okay, let me do it here. Okay, good. So this is your AB. Okay, this is your AB. So what I'm going to do is, just now I try to follow your this line, right? And I realized over here is 3 unit, and then over here is 2 unit. And then for this line, I realized this is 4 and then this is 1. So basically the dimension, they don't match each other. So that tells me this line is actually not equal to this line. Okay, that is one way I can tell this line is not equal to this line. Of course, another way to look at it is I use a measuring tool just now. Over here is 1.01 inch, and over here it appears 1.08 inch. So there is another way I can verify these two lines, they are not the same. So this is not an isosceles triangle. So what I'm going to do here is this. Let me pick another point. Let me pick another dotted point. So let me pick another dotted point over here. Okay, such that the dimension they tally. Okay, so I think let me add one line first. So let me start with this. I go up 1, 2, 3, 4. I don't know yet. I'm just trying. Okay, I'm just trying. So let me go up by 4. Let me go up by 4, and then with this, let me go to the right by 2. Okay. In fact, I am also testing. I don't know. Okay. So I go up by 4. I go right by 2. So similarly, this one, I'm going to go down by 4. Let me use a different color to differentiate. So I go down by 4. 1, 2, 3, 4. Okay. So I'm going to use a different color. And I'm going to go down by 2. Okay, I'm going to go down by 2. Okay, so with this, I think the dimensions is 4 by 2. Okay, for both the yellow lines and the red lines. Okay, so now let me connect. Let me connect this. Let me connect it. Let me use a different color. Let me use a yellow one. Yes, yellow one. And let me get this. Another yellow one. Okay, good. So with this, I think these two yellow lines, they are the same. They are of the same length. Why? Because I make use of the dots. Okay, in fact, I make use of the dots here. So what I do here is I know over here is 4 unit up and then 2 unit to the left. So similarly, here is 4 unit to the right and then 2 unit down. So can you see that? Can you see that these two triangle, these two right angle triangle? Let me demonstrate to you. How do I ensure that the two lines are the same? So can you see that this triangle, this right angle triangle with 4 unit as the base, 2 unit as the height. So it has this length, right? So let me move this triangle. I have not changed the size of the triangle. So what I'm going to do is I just rotate this triangle only. So let me park it here. Okay. Okay, can you see that it turns out to be, it does not fit very well, but it should be good enough. Okay. Because, okay, first thing first, over here, is not very accurate because of the thickness of the lines. That's number one. But generally, if your base is 4, the height is 2, so you just need to get the base is 4 and then the height is 2. So you will get two lines. These two yellow lines, they are the same. Okay, so that's how you form the first isosceles triangle. Okay, so next time, please make use of this technique. Okay, to sketch. All right, so far so good.
Yes.
Good. So therefore, this is your point C. So let me mark your point C. Okay, let me mark the point C here. So this point is point C. And they ask you to find, they ask you to get another what? They ask you to get another ABD. ABD. So let me see. ABD. So another point such that you get ABD. ABD means, okay, for ABD, right, you have to make use of your AB, you know. Okay, you have to make use of this line once again. That means they fix the base for you. So it means you cannot use other lines. You have to make use of this AB. Okay, use black. Okay, you have to make use of AB. And then your D can be here. Okay, this side, or your D can be this side. Okay, I don't know which one can help me to achieve that, but let's try. Okay, let's try. So make use of this concept. Can you spot the D? I think you can draw on this you can draw on this on this screen, right? Can you pick another point D such that you get a isosceles triangle using this concept? Can you try? Instead of label the D, can you just mark the point that you think is the D? Hold on. Let me make the figure bigger. Okay, so which point is the D? Not too big, because once is too big. Okay, you mark your D here, right? A, B, D. Then it's a straight line. It's not an isosceles triangle. Okay, AB is this line, okay? This is AB. So you need to mark a point somewhere here or here. So can you get the point D? Cannot. Hello? Cannot. Hmm? No need to mute yourself lah. Unmute. Can't hear from you at all.
Can you say again?
No. Okay. So can you make use of the technique just now? Okay, to find to find a point D such that you form an isosceles triangle ABD.
So not ABC.
No, ABC is one of them already done. You have done part one. Okay, the question is you need to get a ABC, which I have already done. So now you need to get ABD. Okay, so which is the point D anywhere in the diagram, you can put such that you will get another isosceles triangle ABD. C is done already. Can you identify the dot here in this diagram to put your D? Okay, you choose that point. Okay, so you are taking this point, I assume. Okay, let me help you out a bit. So basically, you are taking this point. Okay, can you erase your handwriting? Okay, so basically, you have chosen this point, right? Am I right?
Yeah.
Okay, good. Let's check if this point can achieve a isosceles triangle ABD. So what I'm going to do is, like I said just now, what I'm going to do is I'm going to just make use of this technique. So I'm going to go up. This is 4 units. So this is 5. This is 6. Okay. So you go up by 6 units, and then you go right 2 units. Okay. So let me write the 6 here. So what you have done here is this. So you go up by 6, and then you go to the no, start from here. So you go to, so it's a 6 by 2 lah. So basically the right angle triangle you have picked is base 6, height 2. So similarly, from your this B, right, do you get 6 and 2? So over here is 1, 2, 3, 4. So it's 4. And over here is what? 1, 2, 3, 4. Oh, no. So your this side is a 6 by 2, but your right side is a 4 by 4. So given this, do you think your answer is correct?
No.
Yes. Okay. So that is how you can verify by yourself. Okay. This answer is very likely to be wrong because these 2 right angle triangle, it must be right angle triangle. This look two right angle triangles, they are of different shapes. Over here is 6 by 2, 6 by 2. Over here is 4 by 4. And I think you can see the area of this triangle is actually what? 6 unit square. For this is 8 unit square. So what it tells is this area, this triangle, this area is different from this area. So if they have different areas, very likely they are these two sides. Which two sides? I mean this one. They are this side. They are these two sides. They are very unlikely to be the same. Okay. So that means your this point is not right to form an isosceles A, B, D, unless you are telling me you want to test this side and this side. Okay, so what I'm trying to say is, unless you are talking about this, let's say you form a line here. Let me change this color. Unless you say this line is equal to this line, and it's very hard to verify. Can you verify this line is equal to that line? I mean this line, the purple one. So let me make it thicker. So unless you're telling me your purple line here is equal to the black line, can you verify that? Can you verify? I think you can start to do this. Okay, so the purple line is 6 to 2. Okay, your purple line here is 6 to 2. So what you need to do is you also count here. 1, 2, 3, 4, 5, 6. Okay, so it's 6 here. So for this one is 6. And then this one is 1, 2. Okay, good, 2. So that means your isosceles triangle ABD is formed. This point is okay, but your isosceles triangle now is this. Okay, let me change this to a purple line. Okay, so your isosceles triangle ABD is an isosceles triangle with what? With this side equal to this side. Okay? Cannot?
Can.
Good. So your answer is correct. Okay, but I want you to realize one thing. Your answer is correct because this and this, they are the same. But if you assume just now, I don't know whether you have assumed or not, but if just now you think that this is equal to this, then your this dot D is incorrect. Okay, so I want you to realize this. Okay, Ken?
Okay.
So so these two sides are the same. Okay, by using this, so this is 6 unit and then this is 2 unit. So similarly, this is 6 unit, this is 2 unit. Okay, so these two sides are the same, and then for the yellow one, these two sides are the same. Okay, so that means for this question, right? For the question here, so not only you need to draw the lines. Okay, I think you have drawn the line. You also need to label which two sides are same. So for this question, I think you are wrong. Okay, this side and this side, they are not equal. Then for this one, we are talking about this one now. This is not ABD already. This question is, in fact, if you have drawn this triangle, right? This triangle, you never make use of the A and B at all. So you never make use of A and B at all. So you have created a isosceles triangle on your own. So definitely this is wrong. Okay, can? Okay. And then of course, once you have drawn the isosceles triangle, you need to tell people by signaling to people which two sides are the same, like what you have done here. Okay. So similarly, if you have drawn it, this way. Let's say you want to tell people this A, B, D. So basically, the A, the B, the D here, they are isosceles. Please tell people these two sides are the same. Okay. If you never label, it's really hard for people to tell which two sides are the same. Or of course, you don't label incorrectly. If you label these two, right? If you label these two, they are the same, then you are also wrong. Okay, you get the point?
Yeah.
Good. So it's good that we clarified. Okay, we clarified. Okay, we clarified. Your answer D is correct, but you must label the two sides are the same correctly. Okay. Okay, let's move on then. So please remember this concept. Make use of the this, like go up by how many unit, go to the right by how many unit. Okay, this is the concept of a right angle triangle. Okay, this is the concept of right angle triangle. So over here. So this is the concept of right angle triangle. Okay, so with this, right, let me continue to talk about the concept of right angle triangle, because your school might not teach you this concept, but I want to share with you this concept of right angle triangle. Okay, so just now what we have is we make use of this concept of right angle triangle, okay, to find this side. Okay, so now this is called a right angle triangle. Okay, and I'm going to give this right angle triangle some names. Okay, for all the sides. Okay, maybe I should not use this. Okay, so I should just use this. Okay, this is called the base. Yeah, no problem. Okay, and this is called the height. I think you also have no problem. And I want to introduce this new term to you. This is called the hypotenuse. Hypotenuse. Okay. You might not need to know the spelling, but at least you know it's called the hypotenuse. Okay. And then I think my spelling is also, I'm not sure about my spelling here. But anyway, just remember that this is called the hypotenuse. Okay. Or short form hype. Okay. The name for this site is called hype. Okay. So just now we make use of this concept of the hype. Okay. Meaning what? Meaning if the base is 4, and then if the height is 6, okay, and then if you use if the base is 4, the height is 6, and then if you use the same dimension you form another right angle triangle. So let's say you form another right angle triangle here. Or maybe I should just copy this. No. How do I? Okay, good. So let me copy and paste. Good. So this right angle triangle is the same as this. Okay, and then no matter what you do, you can rotate it. Let's say you rotate it. Okay, as long as you have the what? As long as you have the base is, in this case, okay, in this case, I think you can take this as the base. You can take this as the base and take this as the height. Okay. The reason is you have rotated it already. So over here, the base is what? The base is actually 6, and then the height is 4. Okay. So as long as the dimension is, so over here the dimension is 6 by 4. Over here is 4 by 6. So as long as the dimension is the same, right? Okay. The hypotenuse is the same. Okay. Just now we make use of this concept. Okay. But from now onwards, I'm not talking about this concept. I want to go further than this. Okay, there is a formula for such. Right angle triangle. Okay, so the formula is, let me create another slide. The formula for this is actually called, I'm not sure if you have heard this before. Okay, the formula is called Pythagoras theorem. Okay, it sounds very, very complicated, but actually the formula is very simple. Okay, so the formula is this. Okay, the formula is, so this is the base, this is the height, so this is called the hypotenuse. Okay, I use short form. Okay, so the formula is b squared plus h squared is equal to hyp, I mean the hypotenuse squared. Okay, so this is the name for this is called Pythagoras theorem. Okay, once again, the spelling is very complicated, so most likely I will misspell it also. So I'm not going to give you the name for this formula, but just memorize this formula. Okay, so how can you make use of this formula? Okay, so let's say that your b is equal to 3, and then let's say the height is equal to 4. So with these two, you get to find out what is your hypotenuse. Okay, so can you figure out what is the hypotenuse in this case? Can you help me out?
Equals to 16, 25. 5.
Yes, okay. So the hypotenuse in this case is 5. Okay, so let me just quickly show you. So this is 3 square, h is 4 square. So eventually you have a 9 plus 16, which is 25. So hypotenuse square is 25. So therefore your hypotenuse, okay, it has to be positive. So your hypotenuse is 5. Okay, so that's how you get hypotenuse equals to 5, right? Okay, so this is just one application of this formula. So please remember this formula. It's called a Pythagoras theorem. Okay, so let's say if let me go back to just now that question. That question just now we make use of 6 and 2, right? I hope you still I especially, okay, at least I still remember. If you cannot remember, okay, I remember. I remember we make use of 6 and 2. We go up by 6 unit and then 2 unit 2 here. So let me just this is called flip. Yes. Okay, good. So just now you make use of this. Okay, so just now we make use of this. We go up by 6 unit. Okay, and then we go to the right by 2 unit, right? So with that formula, okay, so in fact I can get rid of the u. Basically, I take it as 6 cm and then 2 cm, right? And then using the formula just now, okay, this is the hypotenuse. Oh, okay. Let me elaborate or highlight to you. Given any right angle triangle, by the way, this only apply to right angle triangle. Okay, it only apply to right angle triangle. So over here, I should put a note here. Okay, this formula can only be used for right angle triangle. Okay, so only when you have right angle triangle, then you can use this formula, Pythagoras theorem. Okay, only for right angle triangle, then you can use this formula. Okay, so meaning this is a right angle triangle. This is also a right angle triangle. Then you can make use of the b square plus the h square. That means the base square plus the height square is equal to the hypotenuse square. Okay. So what if what if you have a normal triangle? So let's say you have this triangle. What do you think? Can you use this formula to this? The answer is, okay, you cannot, because this is not a right angle triangle. So if it's not a right angle triangle, you cannot, okay, you cannot use the formula b square plus h square equals to height square. Okay, you cannot. So please take note of this. Okay, don't just apply. Okay, make sure it's a right angle triangle first. Okay, good. So this is one thing to note. This formula, it only works for right angle triangle. And then another thing to note, okay, the hypotenuse, okay, the hypotenuse side is always the longest side. Okay, I know sometimes it's very hard to so sometimes it's hard to identify which one is the hypotenuse, right? So let's say if I give you another right angle triangle here, let me insert another right angle triangle. So let's say you are given this, or let me turn it. Okay, how do you decide which one is the hypotenuse in this case? Okay, so over here is also, or rather, they can actually turn it such that your hypotenuse becomes the base. Okay, so let me turn it even further. Okay, good. This is the one. So let me extend it, make it bigger. Okay. Let me rotate it a little bit. All right, good. So in this case, so let's say you are given this. I think this is definitely a right angle triangle. Okay, this is a right angle triangle. So let me make sure. Okay, I label this as a right angle triangle. And then in this case, can you see that this hypotenuse is actually here? Can you see it?
Yeah.
Yeah. So if I never tell you the hypotenuse is the longest side, right? A lot of students, they will never think this is the hypotenuse. What they think, they will think this is called the base, right? And then after that, they will go and find the height, right? So which one is the height? This is the height, right? This is the height, right? Am I right? And then you know what they do? Then they are going to use the formula here. Okay, they are going to use let's say the base here is 3, and then this is 4. Then they make use of this 3 square plus 4 square is equal to 5 square, right? So the hypotenuse is 5, right? They find out, okay, hypotenuse is 5. Then now the question is this the hypotenuse? Is this the hypotenuse? The answer is no. These two are not the hypotenuse. Okay. Okay. So therefore, the first thing to note is this formula can only be used. This formula can only be used for right angle triangle. Right angle triangle. Number one. Okay. Number two, you must be able to identify the hypotenuse first. Okay. So the hypotenuse is what? The hypotenuse is the longest side. Okay. So let's say let's look at this figure. Okay. This figure is, so they have rotated this right angle triangle into this position. Okay. And I think this is a bit tricky here. Okay. If you're not careful, you will think that, oh, this side is the base. Actually, this is also the base, but this is the base, and actually is also the hypotenuse, because this side is the longest side. So therefore, you identify this as the hypotenuse. Okay, so once you identify this as the hypotenuse, okay, of course, What I'm trying to say is, let me crop this out so that I can turn it. And I get it into another slide. Okay, so once you identify this is the hypotenuse. Why? Because this is the longer side. So what you can do next is you make use of the concept just now. Okay, you turn it, you rotate it. So if you identify this is the hypotenuse, then now you can start to label your base and the height already. Okay, then you can make use of the formula b squared plus h squared is hyp squared. So far so good?
Yes.
Good. So two things to take note. Okay, first thing, this formula can only be applied to right angle triangle. Then the second thing is the hypotenuse is the longest side. Okay, so this one is 4. Oh, by the way, you can also use this as the right angle triangle. So this is the longer side for hypotenuse. Okay, so these are the two important things to note. Okay, so this is one of the concept that you can actually make use of to solve harder questions going forward. And I think in the near future, maybe not this time, or maybe I can find another question which you can actually make use of this concept, which can help you solve the question in another way. Okay, I will find a question that you can make use of this concept to solve questions. Okay, good. So I have introduced this concept to you. Okay, good. So let's move on. Okay, question 6. Okay, you're correct. Let me make it smaller. So question 7 also correct. 8 is correct also. This question, what you need to do, just fold the paper and then you should be able to get the answer. Question 10. So question 10 is correct or not sure or what?
Good.
Can you see? Can you help me check question 10? Are you checking?
38.2 and 37 over.
So your answer is a bit off, right? Okay, good. So when your answer is a bit off, so that means very likely it's wrong. So let's look at it together. Okay, over here what it says. So over here it says the table shows the charge for water usage. Okay, so I'm going to get this question into this. I'm going to use this. I think a lot of students, they seldom use Excel. They use PowerPoint a lot. And they also use the Word a lot. And they seldom use the Excel. Okay, so I just want to demonstrate to you, you can actually use Excel. I use Excel as my calculator, by the way. So let me show you how you can actually use Excel to do questions. Okay, let me crop this out first. And Excel is very, very good for you to use if you are doing this type of question, calculation question. Can you see? Good. Okay. So what I have is, it says the first 40. Okay, let me zoom in a bit. Okay, the first 40. The charges is 1.21. And then every additional cubic, so that means every one is 1.52. Okay, after the first 40. So what you have here is, okay, okay. So can I continue?
Yes.
Good. Okay, so it says the Lee family used 32 in June. So 32 in June. So how much did the Lee family pay for the water use? So basically, right, it says the first 40 meter cube, right, per meter cube is 1.21. So 32 is less than 40. So each meter cube you get charged for this. So what you do, you just input the 32 here, and then you just times these two together. Okay, so your answer should be 38.72. And I think this answer is correct. Okay, but now the next question. Okay, so it says the Ali family used 58 in June. Okay, so how much more? So basically the question asks how much more. Okay, how much more? So, but before we find out how much more, right, we need to find out how much Ali family paid for 58. So first thing first, you need to split, okay? You need to split the 458 first, okay? You need to split the 58 first. So what we do is this. So I'm going to split the 58. So 58, I split to 40 and 18, right? Okay, so that's how I split. So the charges for the first 48, okay, is 1.21 per meter cube. So that means what I'm going to do is I'm going to get how much I need to pay for the first 40. Okay, so 1.21. So I need to find out. I times them together. Okay, so Ali family need to pay 48.4 for the first 40. And then you have, Ali family has 18 left, okay, to get charged. So the left 18, Ali's family gets charged 1.52 per meter cube. So 1.52 here. So what do you get? Okay, then after that, you add these two up. Okay, so Ali family should pay 75.76, okay, for the 58 meter cube usage. And then the question asks for how much more. So you just take 75.76 minus off. So I use this minus off the 38.72. So the answer should be 37.04. Okay, so your answer is 37.04. It should be 37.04. You get 38.72. Let me double check. Your first answer is correct, 38.72. But the second part should be 75.76 minus 38.72. So it means this answer is incorrect. This part. Okay. And not very hard, right? To get 75.76. Yeah, so basically you just do this. Can you see this part? Cannot. Hello, can you see this part? Hello. You mute yourself.
I said can.
You mute yourself. How can I hear? You cry for help. I also cannot hear, you know.
Can.
Okay, now I can hear. Okay, so yeah, so you are supposed to do it this way. Okay, of course you cannot use Excel, but the logic behind is this. Okay, so okay, so we take a brief break, then we come back. And by the way, you don't have to mute yourself lah in our lesson, huh? Unless your house is so noisy, you don't want me to hear your noise. But anyway, you don't have to mute yourself, huh? Okay, good. Take a 5-minute break. Come back in 5 minutes. All right. So I will mute myself and then stop sharing first. Hello, are you there?
Yes.
Good. Can you sound more lively?
Okay.
Okay. Your first note is high note, but the second note is dead again. Your O is good, but the K is dead again. All right. Question 11. Okay, you got okay, question 11. Good. Okay, the rest is good. Okay, good. Okay, what happened to this question? Question 15. Question 15 should be quite easy, right? And you only get the first part correct. How come? This is this question is each number total, right? Can you not see? Did you use the each number total method to solve this question?
Nah.
Nah, no. Okay. If you don't use then if you make mistake, then I can't help, right? I can't help. Okay, so let me get this into this. We get it into another page. Okay. Most likely I'm not going to give you the answer, but I'm just going to give you the approach. Okay, the approach how you can solve this question using each number total. Okay. Okay, so let me get this. Okay, so what I'm going to do, I'm going to draw a table. Okay, I'm going to draw a table. Okay, so this is the each, then this is the number, then this is the total. Okay, so over here we are talking about okay, how do I know I'm supposed to use the each number total table method to solve this question? Okay, so I think the question is very obvious. So first thing first, can you see the each here? Can you see the each spoon? Okay, can you see each fork? Okay, so there are plenty of hints. There are plenty of hints. You want to draw something? Okay, so there are plenty of hints in this question. Okay, each spoon, each fork, and we are talking about one fork is how much and one spoon is how much, the kind of question, right? So therefore, over here I should write the heading more clearly. So this is cost per cost. Instead of each, I can use per item. So the two items are spoon and fork. Okay. Next, so after cost per item, the next heading, okay, should be number of items. And then of course, we are talking about cost here, so it should be total cost at the end. Okay, so over here for spoon, each spoon costs 50 cents more than each fork. So spoon is more than fork. So let's say fork is F. Okay, so spoon should be F plus. Okay, it really depends whether you want to use dollars or cents here. Okay, so the question is in dollars. So I'm going to use dollars. So 50 cents is $0.5. Okay, so far so good. So over here it says Mrs. Tan bought some forks and spoon in the ratio. So that means this tells me what? This tells me over here is 4U and this is 3U. Okay, so with this cost per item column filled up, number of item column filled up, you get to find the total cost column. How? Just take this with a bracket. Remember that with a bracket, then you times the 4U, right? Then of course for the second one, the total cost for fork is F times 3U. Okay, so of course before you simplify, before you go ahead, you can actually simplify. Okay, you can simplify this first. Okay, So let me simplify before I continue. So I should get 4f u then plus 0.6 u. So below is 3 capital F and small letter u. Okay, so I have simplified it, and now what I'm going to do is I just have to read the question further. So she spent a total of 156. So that means these two add up to 156. Okay, so let me just copy and paste. So it makes my life faster. Copy and paste. No, I don't want to replace it. Okay, I just want to paste it here. Yes, it's here. Let me drag it. So this one is the total cost for spoon. I'm going to add with this the total cost for fork. So let me add it. And I'm supposed to get 156. And over here, the second statement, the amount she spent on the forks is 12 more. So spend 12 more dollars on fork. So that means the fork 3FU here, right? Yes, so 3FU minus 12 is equal to spoon, which is this one. Okay, so can you not see this is, I think you have learned this before. This is called simultaneous equation. So you have a equation 1. So this is your equation 1. This is your equation 2. Okay. So far so good. So
Yeah.
So what do you have for the first equation? If you continue to simplify it further, so you have your 4FU here and then 3FU. So you end up with a 7FU plus your 0.6U equals to 156. Okay. And then next, what you do is you are going to move. Okay. You are going to move things over. So if you move things over, I mean, you simplify it. What I'm trying to say is you can actually do this. Let me see. You can take this, you move it to this side, so you get a 12 here. And of course, you can move this thing over to this side. Okay, so you get minus 4U, then minus 0.6U, then plus 3FU. Okay, so you simplify further, you will get minus FU minus 0.6U equals to 12. So what you can do is you just punch the calculator. Okay. Okay. I think you still remember how to punch the calculator, right? To solve. Okay. And then with this, I think you can find what is U already. Once you can find what is U, you can find what's F. Okay. So this is the approach to find out hey, I make a mistake here and you didn't tell me. Over here. Okay, so the question you must read carefully. Fox is 4. Spoon is 3. So spoon is 3U. So this one is 3U. Okay. Never mind. So let me correct this. So this is 3U, not 4U instead. But the approach is correct, okay? So must read the question carefully next time. So this is 4. And then of course, this is 3. So remember, read the question carefully. Okay? But the approach is correct. 1.5. So 3FU 1.5. Yes. Yes. Okay, good. So so the formula, the two equation form here is also wrong. So let me just quickly correct this first. But anyway, the approach is correct. Yeah. The method is correct. So correct this. So it should be 3FU. Then it should be 1.5U. Then plus the 4FU. Yes. Then over here it should be 4FU. Minus 12 is 3FU. And then plus 1.5U. Okay, so I'm not going to solve this. Okay, I'm not going to solve this simultaneous equation. So I will leave it to you and you go back and solve it. But the approach is this. Okay, the approach is this. Okay, so go back and solve it, and then you should be able to get the correct answer. Okay, the approach is this. Okay, remember to use this method. Okay, and then if you use that method, and you should not make any mistake anyway. Okay, this question I think we practiced before. So you get it correct or you get it wrong?
I think wrong.
Oh, you get it wrong again. Okay, let's see. You should not get it wrong because this question is very simple and we talked about it last time. So it says what? Jeff had a toy bicycle fixed and then he pushed the bicycle from one end of the track to the other end, and then the radius of the wheel is 3.5 distance between two centers of. So it says what? The radius of the wheel is 3.5 cm. So the radius of the wheel is, so that means this is 3.5. And the distance between the two centers of the wheel is this. Okay, good. The length of the track is, the length of the track means this. 259. Okay, so basically you need to, okay, for this question, right, you need to find out the start point and the end point. By the way, the start point and the end point is not 259. Okay, I just want you to realize the start point to the end point is not 259. Okay, I'm going to show you why. But before I show you why, let me just use a very simple sketch. Okay, let me just use this as a simple sketch. Okay, so let's say this is the start point. Okay, let's assume the radius is actually 1 meter. Okay, so now from here to here, so let's say you really need to start with a reference point first. Okay, so if let's say your reference point is here, let's say you start from so this is here, right? So let's say you okay, by the way, you are going to rotate. You're going to rotate it in this way. Okay, you're going to rotate it this way. So this actually you start from here actually. Okay, and then your end point is where? Your end point is, let me give you a few points. Okay, so this is point A, this is your point B, and this is your point C. Okay, so okay, let's say this is your start point, and this is your start point. Okay, so can I ask you, which of A, B, C point is your end point?
The same point where you start.
So basically you here, right? Okay, so that means you are saying point B is your end point.
Yeah.
Okay, so so how you can actually know? Okay, how you can actually know? Okay, so what you need to do is you just need to so basically you need to imagine. You need to imagine. So what I'm trying to say is this. So you have a ball here. Okay, so you are going to rotate the ball. Okay, you're going to rotate. So let me see if I can actually okay, so looks like it's harder to simulate it here. Let me see if I can simulate it better. Yeah. Okay, so I think this is a very good simulation. So you start, let's say you take this as this one, the middle, as the start point. I'm playing a video, by the way. Okay, so it's pretty fast. So I hope they give you a slow down motion. Do they give you a slow down motion? Let me see. Ah, okay, good. So they are going to give you a slow down motion. Can you see? Can you see? So basically, they are trying to track. They are trying to track how many radius. Can you see? Can you see or not? Okay, so basically what this says is I'm going to get a track out. So here to here. Let me make it thicker. Okay, so what you're going to do is this. Okay, so what you're going to do is this. So basically, let's say you start from here. You start from here. So your ball is going to roll. So basically, this is one round, right? So after you finish one round, right? After you finish one round, this one round should be the distance here. This should be one circumference. Okay, one circumference. Okay, so you just do another one. So you are going to have a second circumference. Okay, so more. Okay, so if you apply this concept to the question, to this question, so if this so basically what you need to do is you bring this back to back. Okay, so this is another 10. Let me erase this to help me out. So what I need to do is okay, so you add 3.5 here, you add 3.5 here. So basically 10 plus 7, so it's 17. Okay, am I right?
It's 18 hours.
Am I right or not?
Yeah.
So then how going forward? Hello.
Take the.
So basically, you need to find out how many 17 you have first. Huh? I mean, within your this 297, can you divide? Can it be? I mean, do you have a whole number? So 259 divided by 17. You cannot get a good number. right?
It's a decimal.
It's a decimal number. Okay, so that means what this means is you don't get a whole number. So that means you don't get so basically you get what's the fraction? Can you tell me the fraction? So 259 divided by
15 and 4 over 17.
15 and 4 over
17.
20.
17.
17. Okay. Okay, good. So basically you have 15 of this. Okay, and of course you have some meters left, right? So so what you're going to do is so just let's find out what's the circumference first. So the radius of the wheel is this, so 22 over 7 times 3.5 times 2, so this is 7. So okay, so it's 22 cm. Okay, so basically one round, okay, let's say if I take this as the start point, one round is 22. Okay, so one round of this is 22. So that means from this point, so the start point is actually 259 minus the what? So this is 3.5. This is 3.5, right? Okay, so 3.5. This is 10. So basically it's 13.5. Okay, so the start point is here. Okay, so 13.5. I start. Then one round of this wheel is 22. So I move 22. So after 22, right, my wheel will be here. Am I right or not?
Yeah.
So continue. Another 22. You will be another. Okay, so basically, let's write down. One revolution is 22 cm. So two revolution is 44, right? Am I right? And then you realize what? You realize that until here is another revolution. I mean, it's the final. This is the final revolution. Final revolution. And final revolution, you still have this 3.5 left. So basically you have 3.5 and then you have 13.5. So that means the distance for you to travel is 259 minus 17. What do you have? You have 242. And then you have 242, then divide by 22. 22 is one revolution, right? So how many revolutions you have? 1/12. Is the answer 12?
11.
11. Okay, so let's look at this closely. So so first thing first. So oh, sorry, help me out. 242 divided by 22 is 11, not 12. Can you help me use a calculator? Double check. 242 divided by 22 is 11. Yes. So I have mental calculation here is wrong. 242 divided by 22 is 11. Yes. Is it 11?
Yes.
Good. So the answer is 11, not 12. Okay. So basically, right, what the question here is, okay. So once again, so basically you have 3.5 here, and then you have 10 here. So that means 13.5 is the distance that you never move. Okay. And then there is a final 3.5 cm. You also never move. Okay. Or you never travel. So basically, total up from this point A to point B, you have 17 cm not traveled. So that's why I need to take the 259 minus the 17. So the distance that the bike has traveled is actually 242. Okay. And I make use of what? One revolution is 22. So I need to find out within the distance traveled, which is 242, how many 22 I have. So basically I have 1122. Does it make sense now?
Yes.
So this question is similar to this. Okay. So what you need to do is this. Okay. So if I make use of this concept, and by the way, this is a simpler question. Okay. This is a simpler question. Okay. So let's say normally they will give you this distance, end to end. Okay, they give you end to end. Okay, they give you end to end. Can you see? This is end to end question. The question will give you end to end, basically from one end to the other end. Okay, they will give you from one end to the other end. And I hope that you know they give you this end to end distance. Okay, let's say the end to end distance is, I don't know, end to end it can be 400 meter. Okay, they give you 400 meter end to end. End to end means the A to B is 400 meter. And you need to know this 400 meter end to end is not, so the 400 meter is not the distance traveled. Okay, some distance within this A to B is not traveled. Okay, so how do you find out the distance traveled? So if you look at the diagram here, you realize what? You realize you have this part. Okay, if you consider this is the start point, so you have this 1 meter. You have this 1 meter not traveled. Okay, and then of course you go and look at the last when the ball hits here, you also have another 1 meter is not traveled. So therefore, if you make use of this concept, you only travel, I mean, the ball only travel what? The ball only travel 400 minus 2 meter. So the distance traveled by the ball is only 398 meter. And then of course, you make use of the distance traveled 398, you divide by the circumference. You divide by the circumference of the ball. Does it make sense? For this question. Okay, so for this question, so you need to find out the distance not traveled. Okay, so you find out that the distance traveled is this 17 cm for this question. Okay, so which two parts are not traveled? So this part not traveled, 13.5 not traveled, and then this 3.5 not traveled, right? And then of course, then you need to minus this 17 cm from the total, which is 259 minus 17, and you get the 242. So the 242 is the travel distance, which is here. So I take the 242, divide by the circumference, which is 22. Then I get to see, oh, 11 are revolutions. Okay, so going forward, please don't make mistake on this question anymore. Okay, I hope I make this type of question very clear to you. Cannot.
Can.
Good. So hopefully you don't make mistake for this kind of question anymore. Okay. This one also wrong. So this one, what happened to this question? So it says AC or AC that this one is 52, and then EF is EF is here, so it's 8, which is here. Then the perimeter of the rectangle and square are the same. So the perimeter of the rectangle A, B, E, A, B, F, G. So that means this one is the same as this one. Then find the area of the figure. Okay, so what I'm going to do is this. I'm going to call this AB. Okay, let me get this AB as my X. So this GF is also X, right? Because they are the same. So for the BC, right, I think you see the BC is Y. So this one is also Y. This whole thing is Y. So can you see that since this whole thing is, okay, this is also Y. Okay, this whole thing is Y. So that means BF is Y minus 8. Can you see? This is Y minus 8. Okay. Then after that, this is Y minus 8. Right? So with all this, I think you can figure out a lot of things. Why? Because you can find that X plus Y is equal to 52, because they say AC is 52, right? So X plus Y is 52. Okay, I can establish this. Then it says the perimeter of the rectangle ABFG. So what I'm going to do, I'm going to add this up to get the perimeter. So it's X plus Y minus 8, X plus this further. Let me plus it again, plus this. This one is equal to the perimeter of the square. So it's Y plus Y plus Y. So it's Y plus Y plus Y plus Y. Okay. Then I think the answer is pretty obvious. Why? Because X plus Y is 52. So I replace by 52. Minus 8, copy down. X plus Y is 52. Okay. Minus 8, copy down. So this is 4Y. So can you help me out to solve what is Y? Can you help me out? What's Y? Where's my calculator? Help me out. Use your calculator. Help me solve what's Y. Are you helping me?
$22.
Okay, so Y equals 22. So with Y equals to 22, I think you can solve all things, right? Right?
Yeah.
Okay, so I'm not going to explain to you further, because once you get Y equals to 22, you can go ahead and solve all things. Okay, so yeah, all you need to do is just make use of this. Okay. Okay, good. So is this the next set of paper? Oh yes, this is the next. Okay, let me go to the behind question first. So you have done 2 sets, is it?
Yes.
Oh, why you? Oh, okay. So you have a lot of time. That's why you do 2 sets. Okay. Before, okay, because I think we are also running out of time. Before I talk about this set of paper, I want to talk about 2 questions. 2 questions I get from Yixing, and I realize it's more relevant. Okay, it's more relevant. So one of them is on circle, and I think I have talked about this concept with you, but not sure if you can remember. Anyway, never mind. Okay, let me just talk about this concept first. Okay, this is regarding the concept of circle. So let me get it out first. Okay, good. So what you have learned in your school is, okay, you have learned semicircle, right? You have learned semicircle. And of course, you also have learned quadrants. And then that's all. Okay, so what I'm trying to say is, okay, I think a lot of students, they have no problem finding area of semicircle or perimeter of semicircle. Why? Because it's half of circle. Then this is half of circle. Am I right? Of course. Okay. So it really depends. Okay, let me just move this. Let me move this thing aside first. So over here, it really depends whether we are okay. So the area of the semicircle is actually half of a circle. This one is definitely correct. But when it comes to the perimeter of the semicircle, right? It might not be half of the circle. It really depends whether the question is given to you like this, or the question is given to you like this. Do you know what's the difference or not between the first one and the second one?
Yeah.
So basically the first one, all you need to do is you just need to find this part, which is half of the circle. But for the figure 2 here, not only you need to find out half of the circle, you also need to add the diameter. Okay, can you see the diameter here? Can you see this diameter? Okay, so for this formula is actually for the figure 1 here. It's for the figure 1 here. Okay, so if you want to find the parameter, parameter of figure 2, you need to take half times the circle and then plus the diameter. Okay, so this is one thing you need to take note. Okay, so now next, so if you want to find the quadrant, which is here, so same thing, area of a quadrant is 1/4 of a circle, right? I think you have no problem. So for the parameter, again, I'm not going to write the full form. The parameter of the quadrant is also 1/4 of the circle. Of course, it depends whether you want to include the radius or not. Okay, let's say you include the radius is plus 2r. Okay, so I think a lot of students, they know what to do with this. Okay, so semicircle, quadrant, I call these two, they are regular shapes. Okay, they are regular shapes. Okay, why 1/4 times a circle? Because it's over here, it takes up, I mean this part here, it takes up 1/4 of a circle, right? And then for this, why half times a circle? Because it takes up half of the circle. Okay, but what if you face irregular shape? Okay, what do I mean by that? Irregular shape. So I mean by this. So you have a circle, but you don't have a regular shape like quadrant or semicircle. So basically, you just have a irregular shape. So how do you figure out this? Yeah, maybe just this. How do you figure out this? How do you figure out the area of this part? Then, given that the radius is 7 cm, then how? Any idea? So this is called area.
7 times 7 times pi divided by half.
Okay, good. So this is not a semicircle, okay? This is not a semicircle.
No.
So that means you need to figure out what is this part in terms of the entire circle. So basically, you have no problem finding out pi r square. This will give you the area of the entire circle, right? So in this case is pi. Okay, let me just make use of 22/7 first. So pi is 22/7. Let's assume that, then times 7 times 7. So the area of the entire circle is actually 22 times 7, which is 154. Okay, so the area of the circle in this case is 154 cm square. Then now you are asked to find the area of this irregular shape. This is an irregular shape. It's not a quadrant. It's not a semicircle. So you need to find out what is this shape. Okay, or rather, what is the fraction? What is the fraction of this shape of the entire circle? Okay, if you know the fraction, then you will know what's the area, right? So if I tell you, oh, this is like 1/7 of the entire circle, then what you do? 1/7 times 154. Why? Because the circle is 154 here, right? Okay, so if I give you the fraction is 1/7, so you just times the 1/7 times the 154. Okay, but how do I know it's 1/7? Okay, so what if they don't give you the fraction, but they give you what? What they can give you instead of the fraction? They can actually give you the angle. They can actually give the angle here. Okay, if they give you the angle here, so over here it must be more than 90. So let's say they give you this is 125. Okay, so if they give you the angle here, okay, you can actually go out and figure out the fraction already. How do you figure out the fraction? If they give you the angle is 125 here, do you know how? You have muted yourself, so I cannot hear you.
Just find 125 over 360.
Very good. So basically what you do is you want to find out this 125 degree is what is the fraction over 360 degree, because what you are trying to do is you are trying to what you are doing here is if the angle 125, okay, to the total, which is 360, this fraction is actually equals to the area of the irregular shape over the area of the entire circle. Okay, so what you make use of is this concept. Okay, so the area of this irregular shape, which is here, over the area of the entire circle, and you should get a fraction on the right here, should be equal to the fraction of the degree. Okay, so the concept here is actually the degree fraction should be equal to the area fraction. Okay, you're actually making use of this concept. Okay, so there is a question asked by Yixing on Saturday. So basically the question gives this. The question gives a similar concept here. Let me duplicate this. Yes, so but I don't need all this. So what you need to do is you need to make use of this concept. The degree fraction is actually equal to the area fraction. Okay, so the question gives, okay, the question gives the area of the irregular shape 20 cm square. Okay, by the way, I cannot remember the exact number, but just take it as 20 cm square first. Okay, good. So now they ask, The question asks, what is the parameter of this part? Okay. So they never give you this. Okay, they just give you that this is 20 cm. Okay, the question asks what is the blue part? Okay, so diameter of the blue part.
Both blue.
No, just no, this is orange. So they ask the blue part. Oh, no, not blue. I'm sorry, yellow. So sorry about it. They asked for the yellow part. Thank you for correcting. So they ask for the yellow part. Okay,
Hi.
so
Hi.
okay. So what you need to do is, you make use of this concept. The degree fraction is equal to the area fraction. So the area fraction is 20 over, okay, over what? Or what is the, okay, they also give the 7 cm here. I'm so sorry. They give you the 7 cm here. Okay. They give you the radius. So you need to use the area fraction. So area fraction is the area of this irregular shape over the area of the circle. So area of the circle is 22 over 7 times pi square, right? Am I right? Am I right or not? So this is the area fraction. So can you help me out? Use your calculator. Help me out with area fraction.
Ten over 77.
Okay, 10 over 77. So the fraction is 10 over 77. Am I right?
Yes.
Okay, good. Yeah. So this 10 over 77 with this fraction, right? You can actually find out what? You can actually find out what is the what's the angle here? So the angle here, I don't know. So I put it as x. And then the total is 360. So with this, can you figure out what is x? Can you help me out? What's x? So you equate these two together. So what's x? Do you know how to solve this? You know how to solve this now? X is equal to 10 over 77 times 360. So what is the fraction for x?
46.75324675.
No, give me a exact one, mixed number.
46 and 58 over 77.
8 over 77. So 46 and 8 over 77.
58.
58 over 77. Okay, good. So this angle is actually 46, 58 over 77. Okay, so with this, I think you can figure out this angle already. Okay, by the way, the question asks this part. So you need to take 360 degree minus the 46, 58 over 77. Then you will figure out the degree here, right? The red one. Okay, so what's the answer? So it should be so what's the answer? Mixed number.
313 and 19 over 77.
Very good. So with this, right? Then now you are asked to find the parameter of the yellow part. What you do, you just take this 313, 19 over 77 over 360 degree and times the parameter of the circle, which is pi 2 pi r, 2 times pi times r, r is 7. So that will give you the parameter. Okay, this part is very easy. You just punch the calculator, you get to find out the answer. Okay, so this was the question I was asked by Yuxing during our lesson. A similar question, okay, not exactly the same but similar. But I just want you to know the concept of this. The degree fraction is actually equals to the area fraction, or is also equal to the parameter fraction. Parameter fraction. Okay. So your school has taught you the regular shapes: half circle, quadrant, 1/4 circle. So I go one step further to talk about the area of irregular shape. So the key is to find out the fraction. Okay, the key is to find out this fraction. So if you are given 125 degree, you need to find out what is the fraction. Okay, because once you found this fraction, you just times the area of the circle or parameter of the circle. Okay, does it make sense?
Yeah.
Good. So with this, I think we can conclude today. So I know we still have this this paper not done yet. So we will do this in our next lesson. Okay. Okay.
Can.
Okay, good. So I think I have a very good session with you. So thank you for your cooperation and your mom's cooperation. Your mom has done great work by scanning these your papers. So keep it up. Thank you so much. Any other question for me?
No.
Okay, good. So before you leave, so I have uploaded your video together with Yuxing's video. So basically your lesson and Yuxing's lessons are both recorded, and I put them all together under one link. So I will update it regularly after the lessons. So you just go to that link and you get to watch your lessons. And if you are curious, you can also watch Yuxing's lessons. So just for the two of you to learn from each other. Okay? Can? Okay, by the way, the recorded videos are for you to do your revision. Okay, Can? Good. So if you have no question, then thank you so much. And that's it. Bye-bye.
Bye.
Bye-bye.